start chapter 19. We're continuing with our circulatory system. We talked about the blood, and so now we're going to look at this chapter that's going to be introducing us to the heart. Because the heart, this chapter on cardiology, the heart is going to be known as our pump. The cardiovascular system, when we talk about the study of the heart, that is, of course, termed cardiology. When we talk about the heart being a muscular pump, yes, because we're dealing with cardiac muscle. You remember we have the three types of muscle in the body. We have our skeletal, we have our smooth, and we have our cardiac. One of the things about the cardiac muscle, it was striated, and we had a nucleus for each cell. And the cells were basically the way the cells were put together. One cell was an intercalated disc to an intercalated disc. So the structure is going to become important. Part of this system is our vessels, something that we've mentioned quite a bit up to this point. What we depend upon is we depend on the heart as a muscular pump, okay? We depend on that to push the blood through these vessels so that by way of an artery, we get to deliver blood to all these tissues of the body, and by way of veins, return it to the heart. So the vessels we're going to be covering also. When we talk about the delivery of blood to the body, we're going to have two circuits. This is how you will see it referred to. They will refer out in the medical world, they will refer to it as the pulmonary circuit and the systemic. And this is the reason why. When we look at the heart and where it's placed, how the blood is going to flow, from the right side of the heart, blood moves to the lungs. That is our pulmonary circuit. It's going to return to the heart on the left side, and from there go to all the rest of the body. The pulmonary circuit. On the right side of the heart, and if we look at the structure, okay, I put a heart for everybody, so get the heart. The right side of the heart, place it like you would think of it being in your chest, okay? The right side, we have our inferior vena cava, our superior vena cava. This is the blood from the body that will be returning. We say deoxygenated. That doesn't mean that all of this blood has no oxygen. It will still have oxygen be present. It's just in low amounts. So what we need for that blood to do, we need for that blood to come back to the right half of the heart. And from the right half of the heart, we're going to learn that it's going to enter my pulmonary trunk, and that pulmonary trunk takes it to the right and left lungs. And that is my pulmonary circuit. The goal is to take the blood that's transporting CO2. Now remember, CO2 is transported, if it's on the hemoglobin, it's on the globin portion, the little tertiary structure of that amino acid chain. And then the rest of it is being transported by way, do you guys remember how we had the carbonic anhydrase? We created the carbonic, does everybody remember that? Okay, so the rest of it is being transported in the blood in this buffered system. That is going to return to the lungs. And the goal, drop off that CO2 so that we can breathe it out, and then oxygen that's in the lungs attaches to the heme groups. Does everybody remember that? So now, once we have that happen in the pulmonary circuit, from the lungs, the blood is going to enter by pulmonary veins to the left side. And on the left side, it will be pumped into my aorta to begin moving through the systems of the body, which is my systemic circuit. Is everybody following me so far? It's my understanding that on the test that you have to take for your chosen program, the heart has quite a few questions. This, of course, is pretty major. Understanding that difference between our pulmonary and systemic circuit. Any questions so far? Okay. The position of our heart, yes, it's about the size of a human fist, maybe a little larger, and it does sit where we would think of it being in our chest. It tilts just a little bit, okay? So if you take the model that you have and place it like you would think of it being in your chest, it's going to tilt at this apex portion just a little to the left. The position is termed the mediastinum. Media, middle, okay? Now, when we talk about the shape of it, when we hear the term base, we tend to think of that as being like the bottom, but this time, when we're looking at this, this superior portion is termed the base. This is our apex, where it comes to a point. Now, at the base, okay, where we're going to see it's wider, it has a lot of stuff that will be coming from it, a lot of these great vessels. That's how they're termed, all right? When we look at the aorta, when we look at the pulmonary trunk, when we look at the pulmonary veins, when we look at the vena cava, these are termed great vessels. You will hear them called the great vessels of the heart. So, One of the things that we're going to see, we're going to have a little bit of a tilt. It is going to have that right versus the left, and when you're looking at a patient, don't forget that's opposite of what you're thinking of, okay? Position becomes very important anatomically for everything. It is about the size of a fist. Here's a couple of things. The heart, I mean, you know, once egg and sperm meet and the heart begins to beat, it's going to do that until you die. That's a long time, because the structure of it, the way that it's going to work, it is pretty much monitoring, okay? It sets its own pace. We don't control that. We affect it. There are things that are present that are going to make sure that the heart has enough room to beat in the chest, and that we're going to see protection of the heart. We're going to find that it has a very nice layers of tissue that we're going to see around it. They create this pericardial sac, which they're showing a cutaway for. But something I want you to note about the sac. Do you see how we've got attachment to the diaphragm? Okay? The structures around the heart, they're helping to hold it in place while still giving flexibility for the heart to beat. This sac that's around the heart, have you ever heard of, for example, pericarditis? Okay, that can be rather, it happens quite a bit in the medical field. What that's telling us, this sac that is surrounding the heart, okay, this pericardium around the heart, okay, once again, we're going to find that it's a double layer that's existing. This outer layer is very fibrous. Fibers, there are 3 in the body: collagen, elastic, reticular. Collagen is the strongest, okay? And do you see how they're trying to show us those fibrous portions? That is helping for that stability, that keeping it in place. This bottom layer, okay, we're going to find it running with what we're going to see, the epicardium. We have in this double layer a serous layer. What is serous? What does that term mean? Anytime you hear that term, fluid is involved. And so this layer is giving rise to fluid that will be found in this sac, in this double layer sac. What that does for us, okay, this fluid that gets created, it helps us to not have pain every time the heart beats. When there is pericarditis, okay, pericardial, itis always means inflammation, okay? So there would be inflammation present, And when this is the case,